All right, welcome to N3ST3DLOOPS. We're doing Chapter 7 of Design Patterns Explained, second edition. So I'll turn it over to Don and we'll get going.
Okay, so last week we talked about the facade pattern, which was a way to wrap one or more objects in another class that would simplify the interface greatly to those other objects or object. Today we're going to talk about the adapter pattern, which is very similar but has slightly different goals and implementation. So to start off with this chapter, we're going to explain what the adapter pattern is, where it's used, how it's implemented, present the key features of the pattern, use the pattern to illustrate polymorphism, illustrate how the UML can be used at different levels of detail, and present some of the observations on the adapter pattern from the author's own practice, including a comparison to the facade pattern. And lastly, we're going to relate it back to the CAD-CAM problem from a few chapters ago. So with the adapter pattern, similar to the facade pattern, our intent is to create a new interface for us to use in our program. For the description for the adapter pattern from the Gang of Four, the goal is to convert the interface of a class into another interface that the client expects. The adapter pattern lets classes work together that could not otherwise because of incompatible interfaces. So in other words, we have the right object that does the right stuff, but it has the wrong interface for our program. So to kind of describe how the adapter pattern works, we're going to look at an example of where it would be used. So in this example the author gives, we want to display shapes on a screen basically, and we're going to create classes for points, lines, and squares that obviously have a different way to display. The client objects, though, they don't know whether they have a point, a line, or a square. They just want to know that they have one of the shapes. So in other words, we're going to encompass these specific shapes into a higher level concept that we'll call a displayable shape. So let's see. What we basically have here is just the standard kind of like polymorphism example with shapes that have different levels of detail, but we just want a very simple interface to them. So we want to have just a subroutine or method that, because when we're dealing with the adapter pattern, sometimes we want to use some subroutine or method someone else has written, but it doesn't fit perfectly into our program. Or the interface or the way of calling the code is not exactly equivalent to the way that it's related to the objects that need to use it. So in other words, although the system will have points, lines, and squares, we don't want them to think about that. We just want it to be seeing them as shapes. And here's a little kind of graphic to display that as even though we have more complex objects, the interface just needs to be to them, refer to them as shapes. And so the usual way of doing this is polymorphism. So we're going to have different objects in the system, and we want the clients of the objects to interact with them in the common way. So let's just jump down to kind of the UML style, not quite UML, but just a simple diagram of how this would work is that we have a shape class and then multiple point, line, and square classes that extend the shape class. And so if we look at the basic behaviors that a shape's going to provide, we have a method to get the shape's location, to set the shape's location, to display the shape, to fill in a shape, set the color, or to undisplay a shape. And then the functionality of the displaying, filling, and undisplaying will be specific to the point, line, and square. So they'll probably need to override those methods. So again, it's just a pretty basic polymorphism example. But now we want to add a new shape. So now let's say that we want to implement a circle. But maybe a circle is kind of complicated with the other things that we've done compared to these other things that have more like points. So we actually want to use someone else's implementation, and maybe somebody else already has a class that's called XX circle that handles circles. But unfortunately, those methods are named completely differently than the ones that we need in our shape class. So it says display it, fill it, see its color, undisplay it, which is very different than what we want to use. You know, we want our program is already written basically to handle the interface to our shape class, not to this circle. But we also don't want to re-implement the whole thing. So yeah, here's the reasons is that I have different names in parameter lists. So they are different from the ones we want to use, and I can't derive it because I can't just extend XX circle because all of our classes that we're using need to derive from shape. So unless you have multiple inheritance, kind of can be tricky, which we'll cover that case a little bit later. But assuming that we only have single inheritance, we need to inherit from shape, not from XX circle. And since we don't want to modify the original class because it would mess up the other person's code, we want to, or you know, maybe we can't, maybe it's a library that we're using like a gem. Instead, we want to create an adapter for it, which is what this pattern is. So what we do is we make a new class that does derive from shape and also implement shape's interface, but it wraps around the XX circle. So it derives from the shape, but it also contains an XX circle instance. And here is kind of a diagram of how that would work. So the circle class just passes requests made to the circle object through the XX circle. So we're making a new class circle that is using the adapter pattern to just kind of forward those messages to an instance of XX circle. And the implementation is something we've kind of seen before. It's very similar to the facade where we have a constructor that is just creating an instance of that XX circle, and it might have to pass some other parameters. We don't know about that. But then the method names we want to use, like display, would then call the existing method names on the XX circle class or object. So the nice thing about this is that we can continue to use the polymorphism with shape. We didn't have to change, you know, the way that our client program was interacting with shape, so we could still use the existing classes, and we also didn't have to rewrite the circle from scratch. So the adapter pattern is most commonly used to allow for polymorphism. That's kind of the goal is, which we'll get into the facade a little bit later, but that's one of the differences is that we usually want something we're using the adapter pattern for to fit into an existing object-oriented design with polymorphism. Whereas the facade, we might not care. We just care about the simplest interface. So then we have the kind of the field notes, the big overview of the adapter pattern. So we're talking about the intent is to match an existing object beyond your control to a particular interface that you do control or that you have already defined. And the problem that we just went over is that a system has the right data and behavior, but the wrong interface. and it's typically when you have to make something a derivative of an abstract class. And the solution we just went over is that the adapter provides a wrapper with the desired interface. So we still get to use the original object, original class, but we get the interface we like. For participants and collaborators, the adapter, it adapts the interface of the adaptee, or the original class, to match that of the adapter's target, the class that it's derived from. In this case, the shape class. And it allows the client to use the adaptee as if it were a type of target, or shape in our case. As a consequence, this allows for pre-existing objects to fit into new class structures without being limited by the interfaces. And as we just went over with the implementation, we just kind of put a wrapper around the original class. And each time you use this pattern, it's going to be different, of course. It's going to matter what the target class and the adaptee class look like, and what's expected by the client. And obviously, the more methods that you have to adapt, the more complicated it's going to be. But the basic thing is that your constructor would be, or at some point you would be creating an instance of that adaptee class, and then passing messages along with the additional methods that you write into the message format that's expected by the adaptee, not the one that we're using to talk to the shape in the case of the shape. So yeah, if we're talking about like Ruby here, it is really just like method delegation in some cases. In some cases, it's going to be more complicated. But when the specific request, the method comes in to the adapter, the request method is the same name as the target class that is extending, but we're just going to call the method of the adaptee instead. And let's see, kind of talking about what he was saying up here is that sometimes there's situations where the object being adapted does not do all the things that you need to do. So it's not just a straight like one-to-one mapping of behavior. But in those cases, the functions that are implemented can still be adapted. You can still use part of what was there. And the functions that are not present, they can be implemented in the wrapping class. So as we see here, with the request, we're just kind of delegating the method to the adaptee. But there could also be a case where we need to do something that's not supported by the adaptee, in which case we would just add additional methods to the adapter. So we kind of get, we get kind of custom behavior, and we get to use the original implementation. And so he says it's not quite the same benefit because you do still have to write some more code, but it does help you still because you still have to rewrite everything. And additionally, what he says is that the adapter pattern frees you from worrying about the interfaces of the existing classes when you're doing the design. You can just worry about the constraints that you want to define for your interfaces, and then your program or your client program doesn't have to worry about a huge variety of interfaces from other libraries, for example. Any questions up to this point or comments?
No.
Yeah, I haven't looked ahead to the questions. So I want to check real quick if what I'm about to say are actually covered by the questions.
Okay.
So actually, what? You still got a couple pages to go.
Mm-hmm.
Define, maintain, consequences, line, variations, implication. It's not similar. Okay. Okay, I can wait until I think after we hit the questions because some of it overlapped with what I was going to say.
Okay, got it. So this next section is kind of getting into some different variations, how you would how you'd use the adapter pattern. So he actually says that there are two types of the adapter pattern. There's the object adapter pattern, which is what we've been using, because it relies on one object that contains another object. Another way to implement, though, is through the class adapter pattern, which relies on multiple inheritance. So the way that this works is that, going back to our previous example, actually just go up to it. If we had multiple inheritance here, circle could inherit from both shape and from XX circle. And now it's not too often that can actually work, especially because he's using Java. So I don't guess there's a way to do that in Java. And sort of, I guess you can do that in a limited way in Ruby as well, but not perfectly. But if you did have multiple inheritance, you wouldn't have to have this situation where you have to create an instance of the XX circle object. You would already have the methods in the circle class because you'd be extending XX circle as well. So in that case, it would just be as simple as the display method calling display it without having to address the object that's being wrapped. And that's the difference between the object and class adapter patterns. But again, it's very similar. It's same concept, the same benefits and the same downsides. If you might still need to add new methods to your class that's extending the adaptee class, but I guess in some cases it could be a little cleaner. So this is what we said, is that each wrapped method calls its associated privately inherited method. That's the other thing, is that the inheritance that you're doing with the existing class needs to be private, whereas your publicly inherited class, like the shape class, we definitely want that to be the public interface, not the XX circle class. So I guess I don't actually know too many languages that would do this, but if you did private multiple inheritance, then that's the way you would do it. So he says that the decision of which pattern to use is based on the different forces at work. And I guess I don't know what different things he would consider besides maybe the language being used. Maybe somebody else has some input on that, but he's not super clear on why he would choose one and not the other. It seems to me like you would have to use the object adapter if you don't have multiple inheritance.
Object adapter, I think, is the default. Even if you have multi-inheritance, because multiple inheritance could be messy. You get that diamond of death. If there's a method in the old one with the same name as the other, it can be confusing. There can be collisions. What I like about the object adapter is the clarity. It's clear to you, okay, my class is exposing the new interface, which he's hiding with multiple by privately inheriting the old one. Like, it makes it clear, okay, these are the methods I'm exposing, and then it's quite clear when I'm calling them. So if I was just looking for maintenance, I think it's easier to look at an object adapter, because otherwise you have some inherit from this and inherit from there, and then I have to jump to two separate parts of code to see first the original interface, and then second, what's available. So I feel it's a maintenance-ly more convenient just to look at the code that way, even if you had multiple inheritance. And the same thing happens in Ruby. You include all these modules. We have our pseudo multiple inheritance. Sometimes you don't know where the method comes from, and you have to look for it.
Yes.
If you are explicitly delegating in the body, it becomes clear. Oh, and if we're going to jump to facade, so sometimes, which the next chapter is about a little bit, right? But next part of the chapter is about if we're writing a facade that has multiple classes I'm delegating to, it's very clear in the facade code. Oh, I'm delegating object 1, I'm delegating object 2. If I were to multiply inherit or include several modules, so I'm back at the same, oh, where does this come from? Well, if you're running prime, maybe you can look for it. But it's like, well, if you don't even have to look, that's kind of convenient. So I think maybe it's just cleaner to do it that way.
Yeah, I agree as well. And maybe that's what he means here, is that if you, during implementation, you see that you have collisions, that kind of thing, or it just looks bad, then maybe you don't do it. And yeah, I would always default anyway to the object adapter pattern. Okay, so then he has there's a small section here comparing the adapter with the facade. And he says a lot of people say that they sound like they're the same. In both cases, there's a pre-existing class or classes that does not have the interface that's needed. And in both cases, we create a new object that has the desired effect. So we have some pre-existing class, and we want to make some object in the middle, or a class in the middle that wraps that pre-existing object, so the client can talk to it in an easier or more familiar way. So both are wrappers. Wrappers and object wrappers are terms that you hear a lot about, and it's popular to think about wrapping legacy systems with objects and make them easier to use. So at this high view, they do seem similar. They're both wrappers, but they're different kinds of wrappers. You need to understand those differences. And to look at those differences, there's a table below. And I apologize that my book, for some reason, is rendering all of this page in bold.
Mine too. I think it's how it was printed out.
Yeah, but I'll read them all out. So are there pre-existing classes? For both the facade and the adapter, it's obvious that yes, there are some pre-existing classes that we want to wrap around. Is there an interface we must design to? Here's where the differences start. With the facade, no. There's not a particular interface that we want to design to. We might come up with one, but there's not one that we need to fit. But the adapter, there always is. So you always have some client that's expecting that it has some specific method names or signatures that needs to call in order to interact with the object you're wrapping. Whereas with the facade, you're just trying to simplify what you have. Does it need to behave polymorphically? Generally, no in the facade, and probably with the adapter. You generally do have some sort of a base class that you're inheriting from in your adapter, which is kind of the point, I guess. Just like we saw the shape before. And is a simpler interface needed? For the adapter, not necessarily, or likely no. You might just have different method names or something as simple as that, like we saw in the example. So it's not going to be simpler in terms of needing fewer methods or, different arguments or anything like that. But for the facade, it is. Typically, we have one or more complicated objects that you want to kind of like hide those interactions into a single method or fewer number of methods in the facade. So while both do have pre-existing classes, again, the facade doesn't have an interface that must be designed to, but the adapter pattern does. With the facade, we don't care about polymorphism, but you probably do with the adapter. And yeah, the motivation of the adapter is not to simplify, whereas it is with the facade. Another point that he makes, though, is that not all the differences between the adapter and the facade have to do with the pattern itself. An example is that some people say that the facade can have multiple classes behind it, whereas the adapter can only hide one. And sometimes that's true. It's going to going to kind of vary case to case, but it's not part of the pattern. It's not defined that the facade is multiples and the adapter is only one. And it's possible that you could actually have an adapter that wraps several small objects, or a facade that only wraps one that's very complex. It's more of the difference, I think, in the simplicity versus polymorphism focus, or the fact that the adapter is trying to go into a specific pre-existing interface. Or sorry, from a pre-existing interface into another specific interface in the case of the shape. Any other thoughts on that?
Yeah, I mean, it is intense. I kind of think of the easy thing for adapter is, I think that the title is perfect. Because for example, my current phone is USB-C, but I've had micro USB phones for like 15 years or something. So I have 9,000 cables. Instead of buying new cables, I have a whole bunch of USB-C to micro USB to USB-C adapters. So what I'm taking this thing that I have that I want to reuse and use it with my new stuff, but the interface is different. So this adapter is dongle. Dongle's not always an adapter. Dongle's just something you plug in. So I have these adapters and quite convenient. And the other cool thing is in the car where I'm using these cables, I can actually use old phone, new phone for that thing. But it literally is adapters. So if you want to take a fairly timely real life example, other people may have micro USB cables. You can just plug in an adapter and plug it in your USB-C phone or laptop or whatever. But you're reusing something in a different interface. So the goal is literally that kind of adapter. Let me put something on top of this class so I can plug it in this other place, which may have polymorphism or not, but it's reuse. It's using something in a different context. Facade is like, I wanted to say that you're kind of cherry picking. You're intentionally changing an interface. With the adapter, you want to reuse something, you're forced to change the interface because you want to reuse this thing in a different interface than it's normally done. Facade is like, something we do, like, I put a facade around PayPal because it's this big, ugly API and it's complicated, and I do 3 things, and I want my method to be not involving 5 classes. So I put a facade in front, I cherry pick, or I simplify, and they're both. There's sometimes you do simplify, or you cherry pick, or you just make the interface easier. Like, yes, I can do this in PayPal with 6 classes and 22 calls, or I can write my one method that I pass 6 things to. Right. So what I think confuses a lot of people is superficially, I don't know, a bunch of patterns are quote unquote wrappers, but there's different intentions and end goals. So yeah.
And I always think of I wrote some code years ago for kind of doing active record style things in Cold Fusion. And anyway, they needed to work for multiple database engines. And so there were already pre-existing classes for dealing with database engines, specific engines. And so writing like a common, I guess, interface, no matter which database you're dealing with, and then having classes that wrap those other classes was kind of the same thing. As you're adapting something that already exists to a new, sometimes simpler way that you want the client to interact with it. So yeah.
Yeah, and if not mistaken, all the database plugins in Active Record are blah, blah, blah. MySQL adapter, Postgres adapter.
Exactly.
Right? It's exactly right. I'm using these other classes and I'm adapting them to the common Active Record interface so that I can plug anything in. The beauty is that if you use Active Record, you only have one interface, regardless of how the interfaces of the actual implemented code.
Okay. So then the last section is just talking about relating the adapter pattern to the CAD-CAM problem from a few chapters ago. So if you recall, the CAD/CAM problem was from Chapter 3, a problem that cries out for flexible code. And it features a V1 and a V2 model for dealing with this problem. And he says that the features of the V2 model will be represented by the OOG feature objects. But unfortunately, they don't have the correct interface, at least from his perspective, because he did not design them. So he can't make them derive from the features class. But when he uses the V2 system, they would do the job perfectly. So in this case, he's saying that he can't write new classes to implement the function. It's not even, implement the function. It's not even present. I must communicate with the OOG feature objects. And the easiest way is with the adapter pattern. So I wanted also to jump back to that so we can see his diagram. And I'm not fully understanding what he's saying with using the adapter pattern here.
Yeah, I don't know if that's a good image exactly. But simply, if you remember, V2 was OO, just different interface, whereas V1 was just straight out methods, and you track the state yourself.
Mm-hmm.
And so for the V2, which of course if I'm talking, you show me and not yours, unless we make you the presenter somehow.
Oh, yeah.
Okay. I made you presenter, so I should be able to talk over your image. So if you look at V1 hole, you can see, I'll start with the very left. V1 slot, this goes and calls V1 system. V2 slot, you can see the little OOG slot. So V2 slot is an adapter of OOG slot. Right, so you can see right there. So the way you implement V2 is you make an adapter and the interface, which largely I think looks like the same, but doesn't say OOG in front of it or something. Yeah, so you can see the bottom row of all the V2s are all the original things. So you're adapting all the original ones, which fortunately have the same class type, regular, special. Yeah. Well, it's okay. If you know you're looking at their adapters, yeah, these are adapters.
I see. So he's not extending the OOG slot is being used by V2 slot.
Right,
so
because the
adaptee is OOG. I wasn't clear in this diagram.
Right, it's somewhere in there. V2 slot inherits from slot feature, which inherits from feature. The polymorphism is in the feature. It's actually 2 levels up instead of 1. Polymorphism is in feature. You have slot feature, whole feature, of which we have V1 slot and V2 slot, which inherit from that. And then V2 adapts OOG into the slot feature, which has, get length unique to feature, but the 3 things in feature.
Okay, cool. That makes sense. So, okay, then he has a quick summary, is that the adapter pattern is a frequently used pattern that converts the interface of a class or classes into another interface, which we need the class to have. It's implemented by creating a new class with the desired interface and then wrapping the original class methods to effectively contain the adapted object, or using multiple inheritance. So review questions. Define adapter, he basically just did is that it's a pattern to convert the interface of a class into another interface, which we need the class to have. What is the intent? And we can jump back to here, is to match an existing object beyond our control to a particular interface. What are the consequences? The adapter pattern allows for pre-existing objects to fit new class structures without being limited by their interfaces. And an example was the circle, the XX circle class with the shape class and the circle class. So we were able to use the XX circle class without using its interface, by instead using the interface we wanted to define to match the shape base class. So which object-oriented concept is being used to define the relationship between shape and point, line and square? And that would be polymorphism, I believe. That's what he's going for. What's the most common use for the adapter pattern? I think kind of what we've been saying is just that you have some class that you want to use that doesn't match what the client expects as far as its interface. So you need to adapt it to that other interface. And I guess specifically you have an interface in mind that you already want to use. Whereas if we're talking about the facade, we just know that we want to simplify whatever the original object interface is. We don't need to adapt it to a specific thing. What is it for you from worrying about? It frees you about worrying about differences between the classes that you wrote and the classes that someone else wrote or that you've brought in from somewhere else. And the two variations are the object adapter pattern and the class adapter pattern. So the Gang of Four says the intent of the adapter pattern is to convert the interface of a class into another interface that the client expects. Adapter lets classes work together that could not otherwise because of incompatible interfaces. And what does this mean? Give an example. So yeah, it's just all the points we've been hitting on is that if you have a client that's already written to deal with a specific interface and you want to add a new class from the outside, then you have to make it match that interface in order for the client to use it. Either that or you have to rewrite the client, which is generally going to be worse. So adapter is an easy way to just wrap that original or the existing object in the familiar interface. And again, an example, we can just go straight back to the shape example, is that the original client could not have used the XX circle object. Question 2 is circle object wraps the XX circle object. What does this mean? It means that an instance of the XX circle object is instantiated within the circle object, and then methods that are called on circle are delegated to XX circle in some way. That's the wrapping. And in Ruby, it's just like the passing of those messages from the object that's providing the interface to the one that's actually doing the work. As we talked about the similarities between facade and adapter, the essential difference is that the facade is there just to simplify, whereas the adapter is meant to match or to make an existing object work with another existing interface. But they are both wrapping an object generally, or objects. Okay, here's an example of an adapter that comes from outside of software. A translator at the UN lets diplomats from other countries reason about and argue for the positions of their own countries in their own languages. The translator makes dynamic equivalent representations from one language to the other, so the concepts are communicated in the way that the recipient expects and needs to hear it. What's another example from real life? We could say Forrest's example of USB and USB-C.
Yeah, I think my example is way better than his. Because I don't know that's kind of weak to me.
I agree, and I would say that because generally methods are an input, not an output, right?
Well, it's too loosely constrained. So if I expect, the interface I expect is English, which is something that most English speakers can't really define that well. So, but you're going to speak to me in Farsi, so you're adapting. I would say that's closer to a compiler, right? Language translation is like compiling, which isn't really adapting.
Yeah, and I also think about like with these UML diagrams and these method signatures is it's the I don't know, it's the message you expect to be able to, I guess, send, not the one you expect to receive.
Right.
Is the way I think about it. So in this case with the UN, they're sending their own messages in the format they want, but the receiver is getting it in a specific way. I guess maybe you could look at it that way, as like that each person's using their own interface.
Yeah. Well, I mean,
it's being relayed in the same. Yeah.
But let's go with probably the universal thing. If I'm going to Europe and I want to use their stuff with my electronics, I buy this travel adapter, which takes my double flat thing and makes it to those gigantic receptacle things that they have in Europe that we don't have. And, changes the voltage, amperage, and the plug. It's literally an adapter. I adapt my thing. That was probably the example he should have used, which is also not software. But then you could go to tools, socket wrenches. Oh, well, I got this unified setup, and then I can use all different kinds of size nuts. And then, in theory, if I had machining skills, if I had a new thing that I could make a adapter that fits one and fits into my socket wrench set. So I can use the same tool set for a brand new kind of fastener thing. Right? That's closer. This language thing, that's kind of weak example.
Yeah.
There's so much involved. It's not a one-to-one. It's not a hey, stop. Describe the weather now in Farsi. Okay. It's not a method I call on Scott. I don't press the speak Farsi button on Scott. I have to analyze and then figure out, oh, well, this is an idiom in English, and there's no real Farsi thing. So, but the intent of this idiom is, don't if you got something there, then don't give it up for the potential that's not. You know what I'm saying? It's like language translation is so much more than that. Because even Google Translate is way more than adaptive. If it were a straight, man is this in Farsi, and dog is this in Farsi, so man beats the dog. But for all we know, man beats a dog in Farsi is some idiom that refers to used car salesman or something. It's so much more. So I think it's such a weak example.
Okay, so I'll move on to the opinions and applications. When is it more appropriate to use the facade pattern rather than the adapter pattern? And how about the adapter pattern instead of the facade pattern? And we can open these up to discussion.
Yes, Andrew should answer them all.
I guess it's a question to answer this question. Couldn't I say, in some sense, that the facade pattern is like a subset of the adapter pattern, in the sense where my requirement for this interface is one that is simpler? Before I make the facade pattern, I say I want a simple interface.
I think you have to be trying to match a existing interface.
Yeah,
is maybe the difference is. I think you're going to more often use the adapter pattern later in the life of a project when you probably already have some existing classes that follow some sort of interface.
Right.
And now you're bringing in something new and you don't want to rewrite all your old code. Whereas maybe I see the facade is more of a one-off thing of, well, I really want to do something complicated and I need to make it look simpler to the client. But I don't have a specific way I want to do it.
Yeah, I think the intent is different. If we go back to the adapter, I'm like the USB adapter. I really want to use these 27 cables I have, but my new phone doesn't use that. So by necessity to reuse it, I have to change the interface. But facade is more you know what, I don't want to deal with 20 classes. I want a class with 3 methods now. Mm-hmm. So it's a convenience thing that is not forced by some outside necessity. You actually determine, hey, you know what? I can't stand this PayPal interface. Okay, well, and I only do 3 things. So why don't I have a class with 3 methods? Which turns around and calls it 26 methods, right? That's me making things better for me. I'm not forced by, oh my God, you have to do the 3 method thing, or you can't use PayPal.
Yeah, and actually when you...
That's adaptive.
Yeah, and when you go look at the definition of the facade pattern in the previous chapter, the intent is that you want to simplify how to use an existing system and define your own interface, so it's similar, but it specifically is where you want to use a subset of a complex system.
Mm-hmm. Yeah.
So I think that's kind of the difference.
Yeah, adapters 1-to-1. I'm using this over there, but the plug doesn't fit. So
yes,
I'm going to make the plug fit. It's called a hammer.
Would let's say an emulator, you know, like if I had an N64 emulator and I download ROMs, would that emulator be thought of as an adapter? Or now I take something used before and I provide a different interface?
There's something for that. There's a pattern. I believe there's a pattern called interpreter or something like that. That's much closer to what that is.
But if you had an existing emulator that worked for multiple, like Super Nintendo and Nintendo, and you wanted to adapt it to, like, adapt an N64 emulator to work on that same emulator, yeah, then maybe that's more of an adapter case.
Well, so if we're going to use a Nintendo thing, so for old console nerds, Super Famicom was the Japanese predecessor to Super Nintendo. And I was in Asia, and I was in Hong Kong, and I had to have my Street Fighter years before it came out to American things, and I went and got a Super Famicom game, which of course didn't fit in the Super Nintendo. But Hong Kong being Hong Kong, I was able to pick one up for like $3, convert Super Famicom to Nintendo. And then of course, pre-TSA, some guy broke into my luggage and stole all my Super Famicom stuff. He left all the rest of my stuff. So when I got back to America, I didn't actually have it. I couldn't use said adapter, but I was able to take otherwise the same game for the same processor with a different card slot shape. I would have been able to use it if it wasn't stolen. But he left me my Super Nintendo joystick, which also had an adapter, because it wouldn't plug into my Super Nintendo. But, yeah. All right.
So just the last question is, why do you think they called it the adapter pattern? It is an appropriate name for what it's doing. Why or why not? I would say it's pretty appropriate, especially because the real world examples are actually literally called adapters.
Yes, the ones that aren't translators.
Yes.
Yeah. All right. Anything? More comments? No? All right. Well, we'll wrap it here. 8 minutes to go, a little short. We'll pick back up on chapter 8 for next session. Are you going to do that again, Don, or should we assign someone else?
Probably somebody else.
I can do it.
No, I'm done.
What?
Just joking.
Yeah, there's Flussing. Okay, Brett will do it. Cool. Last time I heard Brett present it. Okay, cool. Well, Brett will do it next time. We'll see you in 2 weeks. Enjoy.
All right, thank you.
Thank you.
Cheers.
Bye.
Bye.